Then additionally, useful linear algebra, Fourier transform, and random number capability will also be taken a look at. I mean, we will inspect an array with slicing and indexing. That means slicing, trying to get a part of a whole of a data that is of interest for a particular analysis. So the first thing in Python, the first thing you want to do is to import relevant libraries. Like we discussed in the introductory lecture in the morning. Python is a community-based programming language, and a number of times whatever operation you want to perform, you already have something like an object or a whole package that is already had been worked on to do that particular function, function. Sometimes if they don't have, if they are not available, individual could help create those functions and simply upload it and add it to the vast community platform. So here we'll be importing Numpy. All of the package we'll be needing for basic analysis had already been added to that platform. So now, to be able to run this snippet, for example, here is a snippet, a single cell, a cell containing some set of instruction. Now, to run this snippet, you can just click on the play here, or you could click Control Enter. That will still appear. That will still run the snippet. If you click that, the asterisk sign shows that it is still running. So sometimes when you have a large code within a snippet and you run it, it may take a long time for it to run. So if you see the asterisk sign, it shows that the code is still running. So you just have to be patient for that snippet to run. Now, I haven't done that. Now we have a number here, number 7. It means this is the 7th snippet we will run. If I run this snippet again, it means it's the 8th code that I ran within the notebook. Now, we can create an array. A Numpy array represents a contiguous block of memory holding entries in a given type and hence fixed size. The entries are laid out in memory according to the shape and list of dimension size. So let's start creating an array from a list of their integer and taking a look at it. So we could create an array. Then we can visualize the array and also see what kind of an array it is. Now, to create an array inside a variable A, we use NP. We have imported NumPy as NP. So it means henceforth, when we are trying to refer to any function within the NumPy library or function, we can simply refer to it, call it using these acronyms NP. So np.array, we are asking we are calling on the array function to create an array of 1, 2, 3. Now that's a 1 by 3 a 1 by 3 matrix, right? So you have A. That means we are asking to visualize A. Now, if I run this code without the A, so let me just comment it. If I run it without A, there isn't an output, but we have created the array and we have stored it in this variable A. But now, if I uncomment this and I put just A, it means I'm asking the algorithm the program to print the results or the values that have been stored in A, in variable A. So if I launch it now I'm able to see the exact variable that I've stored, the exact data that I've stored in variable A. Now we can inspect the number of dimensions our array is organized along with. Then end time, that means what dimension it is, then and how long each of these dimensions are with shape. So now, if I run a dot end time, so I'm asking what is the dimension of the array in A, right? So it simply will give me the dimension of the array in A. What if and the dimension of the array is 1, it's in 1 dimension. So it means, for example, let me add another cell by create m np dot array, and I create more than a dimensional array, then comma, and I create another one, maybe it's 902, then I close that. If I okay, what is that? Feed elements must be okay. Now, now if I have that and I ask to view M. Now, if for example, instead of asking just the dimension here for the A, which is just 1, let's see what dimension that will return for M. So M dot N dime. So it simply tell me that it's a 2-dimensional array because I have it in 2 dimensions. So I will just close that. But that's just for us to be able to get it done. So done. Now, you could also know the shape of the array by simply just using the shape function. So if I have a dot shape, it tells me that the array is 1 and the shape is 3. So there are 3 columns within that. So finally, we could also ask the kind of data type that A is. Data type is very important in programming generally, not just in Python specifically, because if you want to perform specific operation, you need to be able to know the data type, because the operation you want to perform and the operator will depend on, the kind of operator you will be using will depend on your data type. And for example, if you are trying to also make comparison or do certain arithmetic or even logical operations, sometimes you must be able to know what the type of the data are, so that you are able to know if the logic can work or if you have to convert the data type, so they will have a uniform data type for easy arithmetic or logic operation. So a dot type, that simply will give you the type of the type of that data, A, and here it's showing that it's in 64. So if, for example, we have we can have, sometimes we can have it as character, we can have it as float, etc. So now let's expand this with a new idea, with a new data type, and by using a list of lists, we can grow the dimension of our array. Of course, in real life scenario, especially in climate science, we deal with multi-dimensional array. And it is important for us to look at the array also in a bit of complexity. Now, let's try and I think I even jumped a step. I've been able to explain this earlier while trying to make illustration, but we'll still go through it again. Now, let's create a more complex dimensional array. Not here now, a 2-dimensional array. If we create a 2-dimensional array, we see that here we have 2 by 3 matrix here. If we want to convert that to matrix, if we want to borrow that idea. Now, the dimension here is simply true because now we see it in 2 dimensions. Now, the shape is true by 3. So it is 2 rows by 3 columns. So it means if you have a data, you could be able to use all of these functions to have a glimpse of how the data looks like and the general information about it, the particular data. Now, the data type float 64. You can see the data type here is different from the data type that we had previously. Why? Because now we have the inputs that we have here are actually containing decimals. Int does not recognize decimal numbers. It only recognizes integers. So the data type that recognizes that, float recognizes that. So you see the data type we have here is float 64. So let's make some generalization now. Numpy also provide helpful function for generating arrays of data to save you typing for regularly spaced data. Now, don't forget your Python indexing rules. Now, for example, we have arrange. Arrange, here is the syntax for arrange. Arrange, then inside it, you have the first variable the first parameter is the start, the second input parameter stop, and the third is step. Then if you do this, can help you create a range of values or a range of data. So you don't have to start. And this is especially useful when, for example, when you're trying to plot a graph and you're trying to customize your axis. This can be useful. Also, this can also be useful in other cases. In some other cases, maybe you are trying to make maybe group your data and you're trying to give a condition for the grouping, or etc. So also line spacing behaves similarly. Yeah, can we all mute? Can we all be on mute? Isha. Okay. Okay, I think it's, thank you for that. So line spacing. Line spacing also works similarly. In the case of line spacing, the syntax is line spacing, then you have it in parentheses. Now, the first thing the first input parameter is the start. That means where you intend to start the line spacing from. Then the second parameter is the stop. Then the third parameter is the number of spacing between the start and the stop. For example, if you are starting from 1 and you are stopping at 5, then how many division do you want between 1 and 5? That is the number that is there. So if you want 4 division, for example, it will just divide all the numbers between 1 and 5 into 4 pieces and give you 4 values, which are evenly spaced. Now let's explore the function arrange. Now, if a equals to numpy dot arrange 5. Now if you print that, you have 0, 1, 2, 3, 4. But the question you'll be asking is, since we want it to arrange just 5, why do we have it as 0? And number 2, why is it we don't have the stop and the step, that we only have the 0? Now, whenever you are using arrange and you just put just a single constant, the algorithm assumes that the start is from 0, the stop is that particular number, and it assumes the step to be 1. So it means it just spaces it for you. Now, the way this also works is that it starts the number that you have imputed as the stop will not be included in the range of in the range of values that will be that the algorithm will provide. For example, now we have in here A equals to NP dot arrange 311. We have not put the third input. We haven't put it there, which is step. So, and just like I've said earlier, if you have not put that, the algorithm assume it is what will the algorithm assume to be the step if you have not included the step? That's the third input. Anybody? Let me take the question again. Here we have the first input parameter, which is start, the second input parameter, which is stop. Then we don't have the third input parameter. But I made mention of that the default, if you don't include the third parameter, the default is what? I have stated it, and I want somebody to just remind us, so that I will be sure that at least one person is following.
0.
Huh?
0.
0. You've tried, but there's no. So it's actually 1.
Yes, sir.
Yeah, it's actually 1. So it's assumed the step is 1 if you have not imputed as part of the parameters, the input parameter. So here we are asking it to start from 3 and provide us with a range of interval to 11. So you can see 3, 4, 5, 6, 7, 8, 9, 10. You still will ask why 11 is not there. Just like I said earlier, the stop will not be part of the included, will not be part of what will be included. So it means if you need it to be from 3 to 12 to 11, I mean, the stop will be 12. Now, here we then want to explore all the input parameter. We want it to start from 1, stop at 10, then with an interval or a step of 2. So you see this is 1, 3, 5, 7, 9. So, and this is how range works. Now, the second function that we'll be looking at is line spacing. Line spacing. Now, if b, which is a function, a variable, is equals to np dot line space, and we have 0, 4, 5, right? Okay, and we have 0, 4, 5. It means that we're asked, let's refer back to the syntax so that everybody follows tag along. In the syntax, we said the first input variable is the start, where the line spacing should start. The second input variable is the stop, where you want the line spacing to stop. And the third is the number of interval, that's the number of spacing. Look at the difference. The difference is for arrange is the number of steps. However, for line spacing, it is the number of values you want in between. Now, if you have 0, it means we are starting from 0. 4, it is to stop on 4. Then the line spacing, that means the division should be 5. So, and with that, we have 0, 1, 2, 3, 4. So those are 5 values within the interval. Now, you could look at the shape of B, which is just 5. as we have seen. Now, if you run, for example, this now, you said the line spacing should begin from 3 and end 10. Then there should be 15 divisions in between. That means the algorithm will divide between 3 and 9 and create it will divide the numbers between 3 and 9 into 15 places and display that for you. And that is what you have around there. Now,
Where do you click to display all that?
huh?
Where do you click to
No,
display?
you just simply run the snippet. If you want to run each of these snippets, just click on the play button, or you click Control Enter.
Okay, thank you.
Please try and run each of those cells as I'm going. That is the essence of spending the first 20 minutes to get us to be able to load the Jupyter Hub and get to this point, to this notebook. So each of the line, the reason I'm taking it step by step is so that as I'm going, each person runs the code and you tag along. I have some exercise, I've included some exercises which might not be in the main files, except I've been able to successfully updated it to the server. But I just started those. The essence of that is if you are able to tag along, when you want to respond to those exercises, it is easy for you to be able to respond to the exercises because all you need to do is to run it and just give a feedback. That way, everybody, it's interactive and it's not just a lecture section that people just, it's normal if it's a lecture section that people get bored and get lost. But that is not the essence of the workshop. The essence is to get people to be able to acquire the skills. Is that okay?
Yeah.
All right, thank you. So then we can also, similarly, we can do that for line spacing. So performs the same way as the previous ones, and it's just we could look at line spacing. Now, I want us to create an array with this sequence using line spacing. Yeah, I would like you to use line spacing for this. You can use any of the method with the sequence. It starts from 0, 0. And 1.66, 2.22, etc. Create an array. Just create an array to give this exact value. So I'm giving an int. So use line spacing. Let's see, anybody that gets it first to just share screen. I will stop sharing my screen. If you have gotten it, just try and raise your hand. Then I will share I will allow you to share your screen, or you can just dictate the code. So I will allow maximum for this. And after we will take the questions after we come back, or explanation. Then we will have 15 minutes break. We have like minutes break or 30 minutes break. before we continue.
Sir.
Okay, someone had gotten it right. Yeah. Do you
Yeah.
mind sharing your screen?
I can just dictate the code.
You prefer to give us the code? Okay, please do that.
Yeah. Okay. B equals
B equals, okay, let's use, okay, B equals, okay,
np dot line space
np.line space,
bracket open
okay,
0,5
0,5,
10.
10.
Okay.
Okay, let's run
Call,
that and
then call B.
yeah, yeah.
Yeah, the line space is LIN. It's not LINE. Yeah, okay.
Yeah, sorry about that. So let's run that. Let's visualize that and see if Emmanuel had given us exactly. Yeah, that's excellent. So let's give a round of applause or emoji to Emmanuel. That's excellent, Emmanuel. Thank you. So simply, if next time when you are
Welcome.
given this kind of array and you have already been given an hint as to what to do, you simply look at it. We have divided this into, we started from 0, so it's obvious that the start point is 0. And we stopped at 5, it's obvious the end is 5 for line spacing. Then the division, 1, 2, 3, 4, 5, 10. So it's simply 10 divisions. So that way you are able to regenerate the exact thing. So if, for example, this can be useful for you if you are trying to customize your plots, an axis of your plot, for example. For example, maybe you have a plot of uh, perhaps hourly data. You plot a variable over time in hours, and you discover that if you display all of the hours, hour 1, 2, 3, 4, it will look clumsy. You could divide it into like maybe 4 or like 6, such that it displays hour 0, hour 4, hour 8, hour 12, etc. Or you divide into 6. So this kind of in that those kind of applications, yeah. So we'll be taking a 15 minutes break. We'll reconvey in 15 minutes. That's so that this can allow those our brothers um, in in Nigeria to have their salat, then also to be able to let us have a little bit of rest. Then we'll continue. Then also individuals can go through what we have done to this point so far. All right, so we will convey by 15:10 UTC. That is 4:10 in Nigeria time. 15:10 in Ghana time. I don't know what that would be in US. If anything comes up, I will just send you a message.
Okay.
Yeah, thank you very much. Okay, so let's continue with the tutorial. So we've had a break to be able to, we had a 15-minute break. Okay, we had a 15-minute break to be able to allow everyone gets to the points that we have. So I think most people should have been able to catch up. And now, if we move, we can move at our regular pace now, and be sure that nobody is left behind, since most people had been added to the platform, and time had been time had been given to allow individual catch up with what we have done. Okay, now, constants. True with line spacing. I think we had the exercise line spacing. Okay. Now, performing calculations with Numpy. Now, you can perform arithmetic calculations with Numpy. And Numpy provides a very easy way of being able to do that. Now, normally, if you are not importing Numpy and you literally just want to use Python to run an arithmetic, for example, when you're trying to create a sequence and add up those sequences together, yeah, you have to, the person needs to be able to create the loops manually. However, here, by using Numpy, you could just ask Numpy to do it with a single instruction line easily. Now, let's look at both scenarios so that we can put into perspective how easy it is for us to be able to perform computation in using Numpy. In comparison to the conventional way we would have done it with the same Python if we are not using the Numpy library. So now, here we are trying to generate two-dimensional array. One is a list between 5 and 10, and the other one we are trying to generate a list with an interval from 3 to 0 using this formula. Now, the first thing you might want to ask, okay, let me hold on. If I run it, the first thing you might want to ask is how are these, of course, the first, this first array is straightforward for you to understand how it's been generated, because that is A, which was generated with the range between 5 and 10. But how is the second one generated? Now, to be able to understand that, I have a list here. First, if I create a list from a list, if I generate a list with a range of just 5, it means I'm asking the algorithm to generate a list from 0, 1, 2, 3, 4. Now, it is useful now here. Now it means I have a formula 3 plus I multiplied by 1.5 divided by 4 for I in range 0, in range 5. That means for each value of the range of data or the array that has been created in that range, for each of the value, you are asking the algorithm to be able to generate a new set of a new data based on this formula, while changing the variable I for each time the iteration is done. So normally now, this is the list of the range of value that will be generated in here. So it means for the first one, we have 0. So if you input 3 plus 0 multiplied by 1.5 divided by 4, Using board marks, you will get 3.0. For the second, 3 point plus, now it will be 1, multiplied by 1.5, divide by 4, you get this. For the third time, you put 2. So, and this is what, this is it. This is how this was being able, how you are able to get this. Now we see how we can generate this and do this computation easier with Numpy. Now, after we have gotten those two array of those two array of data, we can then sum up the two matrices, right? So if you want to sum them up such that you have 5 plus 3, 6 plus 3.375, 7 plus 3.75, etc. To be able to do that, we need to write a loop, a for function. We need to write all of this just to be able to do that. Now, let's look at it. If we want to now add this array and this array, instead of writing all this code to be able to do that, which is the conventional way you have to do it with if you are not using Numpy. Now, this is the conventional way. Now, let's see how we can achieve that with Numpy. Now, if we create another set of array, so using arrange and line, let me just visualize A and B. So A, we also want to visualize B, or I can even say A comma B. Let me use A comma B so that I have it side by side. So we have, this is A, 5, 6, 7, 8, 9, and this is B. B is 3, 3.5. So the same thing as what we have above here. The same thing as what we have here. But you can see how easy it is for us with the Numpy package. You see how easy it is for us just with 2 lines of instruction here. We are able to get that done and very simply. Now, if, for example, I want to add A and B, just like we added it here as X and Y, we don't have to run all of this code. We simply just have A plus B. And look at, we have the same answer as we have here with just a single instruction as compared to about 4 instructions here. So that brings into perspective how Numpy library, importing Numpy library had made life easy rather than trying to add code each of the process yourself. And this is how it is for most of the Python libraries that we have. It makes coding easy for us, and that way we can be able to do much with less code, and we are able to achieve a lot of things with less code, just by building on what other people have already worked on and compiled. So we don't have to reinvent the wheel every time we intend to perform certain operations. Now, let's go on to continue with our Numpy. A minus B. If you run that, we simply just subtract the first array from the second array. Then we can have A divided by B. Then we have A star star B. Can someone tell me what this operator star star means?
Okay, I think it means raised to the power, like A raised to the power of B.
Excellent. Thank you very much, Benson. Thank you very much. That's excellent. So it simply means A raised to the power of B. So for example, this is our first, this is the first element in this array. So 5 raised to the power of 3. And that is why we are able to get 125. The second one raised to the power of the second one in the second array, and etc. One thing you need to be careful of is when you are performing operation with arithmetic operation between arrays, those arrays must have the same shape. That means you cannot perform an arithmetic. If you are trying to perform an arithmetic operation on an array with different shape, you are likely going to have error. Now, here we simply just want to see how division works. I mean multiplication. So if you want to multiply, I'm being able to. Sorry about that. Sorry. Okay. So, all right. So you can simply multiply. So this is multiplication. If you recall, the first element in the first array is 5. The first element in the second array is 3. So 3 times 5, that is 15. So, and that we pass it on to all other ones. So it means if you have two arrays of perhaps different variables, and you need to perform arithmetic operation, you don't have to do it one by one. You can simply store them in an array and perform arithmetic operation on them all together. So now let's look at constants. Constants are very useful in science, and Numpy provide access to some useful constants as well. So remember, you should never be typing this manually. Other libraries, example such as SciPy, MetPy, have their own set of constants that are more domain specific. So now here is a constant for pi, np.pi, np.epsilon. You could just get the value. So it makes life very easy for you. You don't have to start racking your brain putting it. Now we could create an array by using this constant. Now we are creating an array. We ask it to start from 0, end in 2 multiplied by np.pi plus np.pi divided by 4. And we ask for the interval to be np.pi divided by 4. So if you just run that, you generate a very unique array. So you could also perform arithmetic operation on this you can perform arithmetic operation on an array that is generated in this way using constant. Here is an array that is generated. You already have an array stored as t, then t divided by np.pi. You simply have an array that you have provided. You already have that function on. Also, some logarithmic operation can also be done. Example, sine, cos, etc. So you could take a sine of, for example, sine t. You have it for each of the operator, each of the elements in that array. You could plane it up and round up. So np.round. So the syntax is you want to round up all of these all the items in this array to 3 decimal places. So if I want to change it to, for example, 1 decimal place, all I'm supposed to do is just to edit that and change it to 1 decimal place. So, oh, sorry, I've not run it previously. Yeah, let me run this cell so I can load. Now, this was what I was saying the other time. You can see the asterisk, which means that line, that snippet is still loading. So you need to be patient and allow it to load, and you don't have to do anything. Once it's loaded, you see the number just appear. Okay, so all right, so I have it loaded. So you can see each of them had been converted now to just a decimal place. Now you can do that for course. You can do that for almost all the trigonometric the trig identities. Now we can convert between degrees and radians with only numpy. You can do that. So if, for example, I convert all of those things that I got initially for T, I could just convert using a built-in function, radian to degrees. So, and I can do that vice versa also. So if, for example, you intend to know the syntax for this, you can just simply check through the documentation. Now, similarly, you could also similarly I'm sorry about, can you hear me now? Am I connected?
Yes.
Okay, yeah. So you could perform all other so now you can have and you can perform an integral using the tribes. You could perform a summation of all a summation. You can also do cumulative sum. All of these are things that are possible with NumPy. So without necessarily having to do that individually on your own. So it's a robust package for operation. Now, indexing and subsetting arrays. Now, you could be able to select individual data points that you need. It's a way of slicing through data. You select the particular data point that you need within a data. For example, this is an array, which is a 3x4. You could, for example, if you're interested in just to pick 5, you can be able to index it and subset these values. And you can do that for a range of value, for a single value, or a range of value. So now let's explore this. So we have np.arrange 12. Then we reshape the numbers of the number from 0 to 12 to 11. I mean, we reshape it as 3x4 a 3x4 matrix. So if, for example, I want to do it again to make it maybe 4x3, I can also do that. So if you run that, you can index, for example, a bracket 0. That means you're only selecting the first row. You can also index by negative index a minus 1. A minus 1, we select. Now, if you are indexing in this way, here is a chart to help. If you're indexing bottommost row, and then it decreases as you move up. So -1, -2, -3, -4, -5, -6. You could also make it in terms of positive selection, 0, 1, 2, 3, 4, 5 downward, or you go back or upward. Of course, you know that -6 is less than -1, so it's still in ascending order, and that also applies to the columns. Now, it means if you have a -1, you are indexing -1 row, it simply will give you the list. That means the topmost row, and that is what you have there. Now, having explained that, if, for example, you are interested in a particular number, you could use the row and column. Let me select this. Now, for example, now, excuse me, please. If, for example, I'm interested in 5, 5 is simply row 2, column 2 by row 2. So it means if I have 2, 2, if I try to index that, I will be able to get 5, right? If, for example, I want to get 6, that will simply be 2, 3, right? So now, armed with this knowledge, let's go on and try to select particular index. Let me clean that. Okay. All right. So let's armed with this, it means if I select the first row and the second column, I should be able to get 6. So let's look at the first row, right? And the second column. This is 0, 1, 2. So, and the second column. Indexing starts from 0 in Python. So now let's look at also -1, -1. So the bottom row, the bottom column. So we simply will be getting 11, right? So here, let me use annotate. So we are simply selecting here and across here. So that's 11, right? So now slicing. Now slicing syntax is written as so I think the connection. So array, start, stop, and the step. So by default, the start is from 0. Then the stop is the length of the dimension. So it means the length of the dimension. It means if it is, for example, 3 dimension, then that's 3 rows. It means the stop will be the third row. If it is 30 rows, the stop is 30 rows. So then the step is one each, one step. So that is the default. So however, in the program, you could change the moment you specify any of these, then it overrides the default. Now, the second column are optional. Now, if, for example, I have B, I'm slicing just a single, I want to slice B equals to A 0. I've only specified the start. I have not specified the stop or the step. It just gives me an array for the first column. Now, laying out our default slice to see the entire array. So if, for example, I want to see B in that perspective, I have 0. We are asking it to start from 0, then to stop at 4, and the step should be 1. So it still gives us this. Now, where again, these default values are optional. Yeah, all of these are being shown here, that all of our default values are optional, or they are optional. So you could either leave it if what you are trying to select matches exactly what will be returned by the default setting, then you may just not put in any of the parameter. Otherwise, you could still state those parameter so that you will be sure that whatever is returned is what you want and you intend to call. Now, slice notation is exclusive of the final index. This means that slicing will include every value up to your stop index and not this index itself. So like a half open interval, end, start, and end. For example, if I have B3, simply just bring out the 3. So if you have B to 3, we've already created B. B is an array from 0 to 3. However, now if I'm only selecting it to start from 0 and end from 3, then I will not be selecting the
Hello. I think Oladipo has lost his connection. Ah.
Okay, hello everyone. Sorry, I don't know. Hi everyone. I think I lost connection, so my Jupyter to take a correct to be able to take. Let's take 10 minutes to take questions and answers. Then those who are lost should to let us know while my notebook is loading.
Abimbola? So Oladipo, so because you got kicked out because of your connection, Abimbola currently has the host rights. And yeah, if she's there, would she kindly
Connection is not yet
transfer?
stable, so I will just relinquish it to have current. I can set up the connection to be stable. So while I'm doing that,
Okay, then she'll hold on to it then.
What do I need to do?
No, please hold on to the host rights. Like, okay, please pause the recording if you can from your end.
Pause the recording. Hold on.
Yeah.
it's also okay if you, yeah, it's also okay if you want to cede the administrative privilege to me. Now, here is our hay, which is a two-dimensional, a 2x3 array. Now, we can get just the row. We can just by slicing, we can slice through just getting the first two rows. We can slice through getting the first two columns, etc. So for example, if we have 0 to 2, that means we are asking it to select the first two columns, the first two rows, I mean. Then comma, we have just this semicolon, just the full column alone. That means it should select all the value for the columns, but just for the first two rows. Now here, we can also do a similar thing. We're asking it to select all the value for the rows, but select just the second column, right? Now, this is just the second column, right? You could do the same thing also with this. Now, here we are selecting just the row, comma. We are selecting the first two. I mean, the first column and the third column, right? So look at, if you compare it here, first and the third, that's 0, column 0, and column 2. That's what we are trying to select here. So you could be creative about this and be able to select either a single element in the array, or multiple elements in the array, a single column in the array, a single row in the array, multiple columns in the array, and they don't have to be consecutive columns or elements. You could be able to select them individually using a set of rules. So also you could use a reshape to be able to, just like we did previously, to be able to reshape your, to change the shape of your array. You could be able to do that. And what has been done here is we are trying to create a 3-dimensional array now from the 2-dimensional array that we had previously. Now, here here is another example of us just selecting one of the element in the array, and you could select multiple elements also from the array. Yeah, so yeah, this and this are just exactly the same. And also we could use the negative that we learned earlier. We could use it to as a parameter to select our array. We explained how the negative selection works. Yeah, so you could also use that while trying to index and slicing through your array. And that is a general introduction to NumPy. Now there are more resources that you could go through at your leisure. So okay, there are more resources at your leisure. After going through all of this on your own, you could also look at some other tutorial on NumPy. This is intermediate NumPy. Also NumPy broadcasting. You could also, there are additional resources are also available within the coursework, and that would be all for today. So, well, we still have some time for us to be able to rub mind together, ask questions, then make contributions. Thank you very much. So any input, questions? Any questions or input, please? Then also,
Okay,
if you are having issues with setup, you can also ask your question, please.
okay,
Yeah, Benson.
I have a question. When you were given the lecture on arithmetic calculation with NumPy. So I noticed
Okay.
that on the first example, we deal with variable A and B, and we try to compute other functions of A and B, like adding A and B together, multiplying A and B, and stuff like that. Yeah, I see on the second line of the code, I can see I, where they say, okay, A, B equal 3 plus I times. So that I wasn't defined. So I wanted to know why, or is that I, is it kind of a constant? Because it wasn't defined in the code, like I is this.
This place, right?
Yes, so you can see the I, 3 plus I. So that I there, I want to know why it wasn't defined, like as in.
Okay, now, thank you very much for that question. Now, this I, you see, we are saying this is more like a for loop. We are asking the value of I here to be the value, to assume the value of I for each of the iteration in here. Now, this is a range.
Yeah, 0 to 4.
0 to 5. That is the reason I added this line of this line of code. The line of code is telling you exactly what this range is. The range is from 0 to 4. So it means for each of the iteration, you're asking the algorithm to update the value of I for each value within that range. So it means that it will update the value of I 5 times. The first time it will be 0, the second time it will be 1, The third time it will be 2. The fourth time it will be 3, and the fifth time it will be 4. And for each time it updates the value of I, it will compute the value of beta of B,
Entirely.
based on that. So for example, for the first one, the value of I is 0, based on I that has been specified in this for loop, right? Now, if you put 0 here, it means using BODMAS. That means you have to perform division first. So 1.5 divided by 4, right? Isn't it? Multiply by 0 plus 3. So whatever value you have for 1.5 divided by 4 will still be 0, because you are multiplying it by 0.
Yeah, plus
then
3.
plus 3. So it means for the first scenario, that will be 3.
Yeah.
For the second scenario, 1.5 divided by 4 multiplied by 1, right? Then plus 3. And that is when you then have 3.375. Then for the third, that will be 1.5 divided by 4 multiplied by 2, multiplied by 2, yeah, plus 3. And that is what you have. So you do understand that, etc.
I understand. So if I want to make my result uniform, like in the first place I have 5, 6, 7, 8, 9. Now I want to make the second array, instead of 3.0, 3.375. Now I want to make round up for my result to be uniform. For example, this first one here, 3. Then the second one will be, since it is 3.3, I just leave it as 3, because you can actually round up 3. So then the next one will now be 4, and the next one will be 4, just like that. So how do you compute code for that?
No, simply you just use, there's a function round. I think
Okay, yeah,
it was used somewhere. Yeah, you simply just you can just simply use that, and that will be able to the way the function works is np.rand, all those b, you simply just insert b, then comma, then you state how the decimal place you want it to be.
Okay. Okay.
So, and that's what you do. So this snippet is only showing you how this snippet, forget this snippet, I only included it because I want you to be, I figure out people may need to understand exactly what is happening here. So that's the reason I inserted this. So I will just minimize it. Now, this snippet and this are doing exactly the same thing this snippet is doing.
Yeah.
Right?
Yeah.
Exactly what this snippet and this snippet is doing. So those snippets are the essence of having this and this to generate this result, and this to generate the same result, is to put into perspective the ease with which the use of libraries, the ease that the use of libraries offers when you are trying to write Python language. That if you're going to use libraries, you will be condemned to write a lengthy code. However, if you are able to use libraries, the process of writing, you will be able to do the same thing with little code. And that will make your prototyping or whatever operation you are doing faster. So it's just to put into perspective how important the use of library is, and by extension, the impact of the community support that Python enjoys.
Thank you very much.
I hope I'm able to answer your question, Benson.
Yes, thank you.
Right, you're welcome. So, we have come to the end of today's tutorial. Thank you very much for being here, and we still have we have a ton of events for you. You are welcome to the COESSING once again. You are welcome to COESSING 2023. and I wish you a fun-filled and delightful summer school. Thank you very much. I will see you around during the week. Bye-bye.
Please, can I ask a question?
Please, you can, please.
I just wanted to find out the software for the Python installation. I was not able to
Software for
join the Python installation. I couldn't join the earlier program. So I wanted to find out how can we get the software to install in our computers.
Okay, you need it. Wait, let me first trash this out first. Now, there are a number of ways that you can be able to use to run Python code. You could run it locally on your computer, right? In fact, there are also ways for you to be able to run it on your PC, on your mobile phone.
Okay.
Then you can run it on cloud. For this summer school, we have adopted the cloud computing.
Okay.
The reason for adopting the cloud computing is all the dependencies and the application that you need is already on the server that we are using. So you are only supposed to just log into that server to be able to access and run your code. However, if you intend to also want to have it installed locally, so that even if you don't have internet connection, you will be able to run your code. Then there's another process we could, I think we have a recording for that. Then if you have, I will ask if we have recording for that. If we do, we'll just send you the video for that. If we don't, I can simply just have a one-on-one period with you, maybe at your convenience.
Okay.
Yeah, then I'll put you through that.
Okay.
But currently, do you have access to the Jupyter Hub that we are currently using?
What you have asked us to, I have it.
Okay, you have access to the online platform, the Jupyter Hub.
Yeah.
Okay, so you only need the application on your system so that you can run it locally, right?
Okay.
Okay,
yeah.
So I don't know, Daniel, do we have the recording for it?
Yeah, there's a recording for it.
Okay,
it's in your emails,
right.
and it's already been shared. The links to the recording have already been shared to their emails here.
Okay. And thank you very much. I'll look at it.
All right, thank you, Daniel.
I'm grateful. Thank you, too. Yeah.
All right, you're welcome, Fusiani. I hope I got the pronunciation correct.
Yeah, you've gotten it right.
Yes, and also I'll just make a quick announcement. So also in your emails, a link has been shared to join the COESSING Slack channel. So if you've not joined, please try and do so, because it's more easier to interact with instructors there. It's more easier to handle your problems outside of the tutorial sessions. If you have any problems, it will be easier for you to get in touch with us whilst we don't have a tutorial, and then we can follow up on your issues. So please try and join the Slack channel. Thank you.
All right, so thank you very much for today. We'll see you around. Okay, is there any other announcements, Daniel?
No. We'll see them tomorrow.
We'll see you tomorrow morning.
Yeah.
Thank you. All right, bye-bye.
Bye. You're
Bye,
recording.
Dr. Ola.